Hello, my little minions. Welcome to the video tutorial. Today we are going to be, well, I say today, you're probably cramming for your test right now. So tonight, this video tutorial is going to help you with Sig Figs. So, significant figures they are what tells us the precision of our instruments. So the more sig figs you have, the more precise your instrument is. Now, precision and accuracy we know are two different things, because if you imagine a bullseye, and this is going to be a very lopsided bullseye, but there's the bullseye right in there. And my first group of shots are coming in hot over here. Okay, and I've got very nice grouping, but what I lack is accuracy. So what I have here is what we know as precision. Precision. So if I come in and my next round and I am all over this thing, I'm on fire, I now have accuracy. Okay, so sig figs can't really tell us our accuracy, but what they do is tell us our precision. Now, on your test, you will have to do some operations with significant figures. So there are some rules to follow when you are doing these operations. So let's start with multiplication and division. Okay, so let's say we've got, let's go 3.4120, and we are multiplying that by 4.5. Now, it's important to know what numbers are significant and what numbers aren't. So, any number that is not 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, those are significant. Okay? Any number that is not significant, or that is not 0, is significant. Now, what gets tricky are your zeros. So, trailing zeros after the decimal count. So those zeros are significant. So this number right here has 1, 2, 3, 4, 5 sig figs. This number has 1, 2. So if you plug this into your calculator, 3.412 times 4.5, you get an answer of 15.354. Let's go ahead and get rid of that, and let's change that to a 5. So 354. Now, plugging it into your calculator, it will give you 1, 2, 3, 4, 5 sig figs. Your calculator doesn't know anything about significant figures. Okay? It doesn't know about the precision of your instruments that you've been using. When you're multiplying and dividing, you find the number that has the least amount of sig figs. Here's this, 2. So our answer can only have 2 sig figs. So you go to where the second sig fig would be, and you round accordingly. So our answer would just be 15. Okay? So that's multiplication and division. Find the number with the least significant figures and use that number for your answer. Now, what about adding and subtracting? Okay, so let's say we've got 0.0001, and we are going to take away from that 4.5493. So, another rule here that we're going to illustrate. Here we've got more zeros. Now, these zeros are trailing after the decimal, but now we've got a little stigma that we need to add. Trailing after this decimal and after an integer. So they need to be after the decimal and after an integer. So, an integer is any number that is not 0. So if we look at these zeros, yeah, they're after the decimal, but they're not after any integer. So this number only has one sig fig. This number has 1, 2, 3, 4, 5 sig figs. If I added a 0 over here, it would jump to 6 sig figs because this 0 is after the decimal and it's also after an integer. So with adding and subtracting, the rule is a little different. What you do is you count the number of significant figures to the right of the decimal. So here the number stays the same, it's just 1. Over here it has 6 total sig figs, but it only has 1, 2, 3, 4, 5 sig figs after the decimal. So since we're adding and subtracting, we care about the number 5. So if we plug this into our calculator, 0.0001 minus 4.5493, calculator spits out for us negative 4.5492. So we look at our numbers, our significant figures after the decimal. The lowest number is 1. Therefore, we can only have one number after the decimal. Okay? So, here's our number. We look over here. It's 4. That rounds down, so we go negative 4.5. One number after the decimal, one number after the decimal. Now, what if we have a mixed operation? Say we've got 4.699102, and we are multiplying that by 33.2, but then we are going to subtract 14. So, how we start? We're starting with multiplication. So let's count our sig figs. Now, another 0. This 0 is sandwiched between two integers. That 0 is significant. Any 0 that is between two integers is significant. So this number has 1, 2, 3, 4, 5, 6 sig figs. This number only has 3. So, we carry through our operation as normal. So we go 4.61 or 4.69102 times 33.2. Now the calculator is going to give me 155.74 186 la 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 la. It'll keep going. And then we still have our minus 14. Now, how many sig figs should I have in my answer? We're multiplying, so I look at the lowest number. It's 3. So my answer should only have 3 sig figs. So if I look at this, 1, 2, here's my third sig fig. Round it up, so it becomes 156 minus 14. Now here I'm adding and subtracting. Now this is pretty easy because I have no significant figures to the right of the decimal. So I shouldn't get any in my answer. Which, luckily for us, you plug it into your calculator, you don't. So you end up with just 142. That would be your final answer. Now, a quick touch on, again, a review on what is significant and what isn't. Say I have 1,000. 1,000. And I want to know how many significant figures that is. Well, here's my integer. I've got 1. These trailing zeros do not count. So as this is written, I would just have one sig fig. Now, what if I went 1,000 decimal? That number would have 4 sig figs. Zeros that are before a decimal count as significant as long as they have an integer before them. So if I had 0.01, that only has 1 sig fig, because these leading zeros don't count. There's not an integer in front here. Now, as soon as I add an integer, that number jumps to 4 sig figs. I've got zeros sandwiched in between two integers. Now, 1 or 0, 1, 0, 0, 0. That number has 4 sig figs. So, very important to know what is significant, and also very important to know how to carry out operations while keeping your precision intact.